In this video we have two integrals to evaluate. The first one involves the exponential e and the trig functions tangent of x and secant of x, in this case secant squared. A lot of times when you have a mixture of these types of functions, it's going to be a U-substitution, or in some occasions it could be integration by parts. My go-to method is a U-substitution. Sometimes they're fairly obvious, sometimes they're not. These two are pretty straightforward. The u is generally going to be equal to something that may be a power. It would be something in the denominator or some kind of factor in the numerator. So here what I'm going to do, I know that the derivative tangent is secant squared. That gives me an option then to let u equal tangent of x. Then du would equal to the derivative tangent is secant squared of x dx. And notice I have secant squared of x dx, and I've got it right here in the integrand. So I want to transform this into a integral involving the variable u instead of x. So this can represent du. The tangent of x I know is u. So follow up over here, then this would just be the integral of e, and tangent can be replaced by u, and secant squared of x dx right here is your du. And then of course what are your basic formulas? The integral of e to the x dx is e to the x plus a constant. Well, if you have e to the u, and the integral of the variable of integration is u, e to the u du, it's just going to be e to the u. But you got to go back to the original variable. So instead of putting e to the u there, I'm just going to put e to the tangent of x plus the constant of integration. So we get e to power tangent of x plus c. That takes care of that one. Now in the second one, we got x squared plus 2x plus 3. That's in a parentheses to a power. Sometimes you can equal to this, what's inside the parentheses. I got another one over here. But it makes more sense to do this. I'll let u equal to x squared plus 2x plus 3, because then du would equal to the derivative of this, which is 2x. Derivative of 2x is 2. Derivative constant is 0, so I get 2x plus 2, and then I multiply this by dx. So I'm trying to transform this integral to the variable u. Well, I know that u is this, based on the substitution. So this is going to be u right here. That's in terms of u now. Now, can I get x plus 1 dx in terms of u? Well, from right here, factor out a 2 here. Let's just divide both sides by 2. And that'll give me du over 2 on this side. Then here, the 2's are going to cancel. So I'm going to get x plus 1 dx. So now this x plus 1 dx can be replaced by du over 2. This then becomes the integral of u, and that's to the 6th power, and then the x plus 1 dx, that's your du over 2, and I'll put the 1/2 out in front, and then I just integrate this with respect to u. So this is going to equal to, add 1 to the exponent there, that'll give me u to the 7th. And then I divide the 1/2 by 7, so that'll be 1 over 14. And that's plus the constant of integration. Then all I have to do is go back to the original variable. So this would be 1 over 14. And the u is x squared plus 2x plus 3, and that's taken to the 7th power. And of course we have the constant of integration. And this is your final answer for this one. Like I said, these were pretty straightforward. There's some U-substitutions, and I'll have one later on in another video where it's not that easy to determine what the U is going to be, or what you have to let the U equal, so that you can solve the problem by applying a U-substitution. Thanks for watching. We'll see you next time.